So now we're going to talk about actually graphing rational functions. So we're going to bring all of what we've been talking about together. So here are the steps to graph. First thing you want to do is you want to factor and you want to find those horizontal and vertical asymptotes and the holes. Now to find so whenever you find your holes, to get the y value, you are going to plug in to original equation. Okay, so that's how you get your y value of your hole. Next, you're going to find your x and y intercepts. Remember, to find an x-intercept, y must equal 0. To find your y-intercept, x must equal 0. You're going to make a table of values based on your horizontal and vertical asymptotes, and then sketch a graph. So let's look at number 1. First thing we need to do, we need to find our horizontal and vertical asymptotes. So horizontal asymptotes, remember it's Bobo Botan eats dark chocolate. In this case, it's going to be eats. Okay, exponents are the same, so we divide coefficients. We will get 3 over 1, which is 3. So my horizontal asymptote is at y equals 3. And I'm going to graph that on my graph here. So y equals 3, horizontal asymptote. For a vertical asymptote, that's the factors in the denominator that do not cancel. So looking at this, we can't factor anything. Nothing cancels, so we set x minus 4 equal to 0, solve for x. So x equals 4, that is your vertical asymptote. So I'm going to draw that on the graph here. Okay, now we need to find x and y intercepts. So to find an x-intercept, y equals 0. So my function here is going to be 0 is equal to 3x over x minus 4. Now the good thing about rationals is that in order for a fraction to equal 0, just the numerator needs to equal 0. So really we don't even need to worry about that x minus 4. We just need to worry about 3x. Well, divide by 3. You still get 0, so my x-intercept is 0, 0, which is also my y-intercept. Remember, y-intercepts is when x is equal to 0, so we do get the same thing. Okay, so right here on my graph, that is my x and y-intercept. Now we're going to make a table of values based on your horizontal and vertical asymptotes. Now, the way that I do this is I look at where my vertical asymptote lies. In this case, it's at 4. So I'm going to take a couple of points to the left of 4 and to the right of 4 and use those to sketch my graph. So to the left of 4, I already have 0. So let's look at 1. 1's kind of an easy number to plug in. So in my equation there, so I will have 3 times 1 over 1 minus 4. Well, 3 times 1 is 3. 1 minus 4 is negative 3, so I get negative 1. That's my coordinate point. So at 1, we're at negative 1. Let's take another point that's to the left of 4. Let's do 2. If I plug in 2, I will get 3 times 2 over 2 minus 4. So 3 times 2 is 6. 2 minus 4 is negative 2, so that will give me a negative 3. So when x is 2, y is negative 3. So based on this, you can kind of start to sketch your graph. Okay, remember it doesn't cross those asymptotes. So I have my first chunk. Now I need my second chunk. I need to look to the right of 4. So let's look at 5. If I plug in 5, so 3 times 5 over 5 minus 4. So 3 times 5 is 15. 5 minus 4 is 1, so we get 15. At 5, we are way up at 15 here. Off the graph, I'm just going to put it up there. So let's look at a number maybe a little bit farther away from 4, kind of get us closer to that asymptote. Let's look at 7. So 3 times 7 over 7 minus 4. So 3 times 7 is 21. 7 minus 4 is 3. So 21 divided by 3 is 7. So when x is 7, y is 7. Okay, and so from there you can kind of sketch a graph. Okay, again, it doesn't need to be perfect, but we want a rough sketch. That is how you graph rational functions. So let's look at another one. So we have 3x minus 3 over x squared minus 1. First thing we want to do is we want to find horizontal and vertical asymptotes. This will include factoring, so I can factor out a 3. I'm left with x minus 1. X squared minus 1 is a perfect square. It will factor to x plus 1 and x minus 1. So we can cancel the x minus 1s. Now, whenever you do that, just know you have a removable discontinuity there. Okay, so we have a hole at x equals, if we set x minus 1 equal to 0, we will get x equals 1. So there's a hole at x equals 1. To find that point, we want to plug it in to our final equation. I made a mistake in the beginning of the video. It will need to be plugged in to the final equation. So if I plug in 1 into my final equation there, I will get 3 over 1 plus 1, which is 3 over 2. So my hole is at 1 and 3 over 2. So I'm going to put that on my graph right now. So 3 over 2 is 1.5, so my hole exists right there. Now let's look at vertical asymptotes. The vertical asymptotes are the factors in the denominator that don't cancel. So we have x plus 1, set that equal to 0, x equals negative 1. So that's where our vertical asymptote exists. Horizontal asymptote, Bobo Botan eats dark chocolate. I would use the original equation for this. So biggest denominator in the numerator is 1, exponent in the denominator is 2. So big on bottom. So this is Bobo. So our horizontal asymptote is at y equals 0. So I'm going to draw that on the graph. Next, we need to find x and y intercept. So x-intercept is when y equals 0. So again, anytime we are setting the equation equal to 0, we just need to set the numerator equal to 0, and we're using the simplified form. Okay, so 0 equals 3, that does not happen. Okay, that doesn't exist. So if you think about it, there is no x-intercept. Well, why? Because the x-axis is an asymptote. We have that horizontal asymptote at y equals 0 here, so it's never going to cross this x-axis. Let's try to find y-intercepts now. Remember, that's when x is equal to 0. So again, in the simplified form, we are going to set x equal to 0 and then solve, so we get 3 over 1, which is 3. So our y-intercept is 0, 3. So I can plot that point, it's right there. And right now you can actually start to sketch a graph of the right-hand side, just using your y-intercept and the hole that we found earlier. So now all I need to do is I need to find the pieces of the graph that are to the left of that vertical asymptote. So again, I'm going to use x values that exist to the left of negative 1. So let's look at negative 2. And again, we're going to plug these into the simplified form. So I will get 3 over negative 2 plus 1. So negative 2 plus 1 is negative 1. So we get -3. At -2, we are at -3. Let's do one more point. Let's look at -3. So we have 3 over -3 plus 1. So we will get 3 over -2, which is -3/2. So that's about -1.5. So at -3, we are at -1.5, which is about right there. Then you can sketch your graph. Let's look at one more. I'm going to try not to mess this one up now. So we have y equals 4x over x cubed minus 4x. So we're going to factor this first. I can factor an x out of the denominator. That leaves me with x squared minus 4, which can factor more because it is a difference of squares. So we have x plus 2 and x minus 2. Now look at what can cancel. We can actually cancel the x's. Now, since we canceled them, that means that there is a whole, okay? And so we set that factor equal to 0. So x equals 0, that's where our whole exists. To find the y value of the whole, you plug it in to your simplified form here. So if we plug in 0, we will get 4 over 2 times -2. So we get 4 over -4, which is -1. So the coordinate point of our whole is 0, -1. And I'm going to plot that right now. So 0, -1, that's where our whole is. Next, let's find our horizontal asymptotes. So think Bobo Botten eats dark chocolate. Looking at the exponents, the largest exponent in the numerator is a 1. In the denominator, it's 3. So we have big on bottom, which means we have y equals 0 as a horizontal asymptote. Next, let's find vertical asymptotes. In the simplified form, set each factor in your denominator equal to 0, that didn't cancel, and then solve for x. So we get -2 and +2. So we have 2 vertical asymptotes at -2 and +2. So now we need to find x and y intercepts. So x-intercept, that's when y equals 0. We use the simplified form, and anytime we set a fraction equal to 0, we just need to look at the top. So 0 equals 4, that's not correct, that doesn't work. So there are no x-intercepts, which makes sense, again, because our horizontal asymptote is the x-axis. It's never going to cross the x-axis. Now the y-intercept is where our whole exists. Okay, when x is equal to 0, we plug that into the simplified form here, and that's where we get our whole. Okay, so our whole is our y-intercept. However, since that whole technically doesn't exist, we don't have a y-intercept. It is not defined on that graph. It is a whole. So now we need to actually find some points to the left and right of our vertical asymptotes. So in this case, we're going to need a lot of points. So let's look to the left of -2. So let's look at -3. If I plug in -3 into my simplified form here, I will get 4 over -3 plus 2 times -3 minus 2. So 4 over -3 plus 2 is -1. -3 minus 2 is -5. So I will get 4 over 5. Okay, so at -3 we are at 4/5, which is close to -1, just not quite there. Let's look at negative 4. If I have 4 over negative 4 plus 2 times negative 4 minus 2, you get 4 over negative 2 times negative 6. So we get 4 over 12, which reduces to 1/3. Sorry, that's a positive 4/5, not a negative. So positive 4/5 at negative 3. We are right there. At negative 4, we are at positive 1/3, so we're about right there. So you can kind of see the shape of the graph. It's going to look like that. So now let's look in between negative 2 and 2. So let's look at negative 1. If I plug in negative 1, I think you've seen me do the math enough times, you're going to get negative 4/3. Okay, so negative 1, we are at negative 4/3, which is negative 1 and 1/3, which is about right there. I'm going to continue over here, so we'll break up the table here. If I plug in positive 1, again, we want to the left and right, or in between negative 2 and 2. So if I plug in positive 1, I will again get negative 4/3, which is about right there. So this middle chunk here is going to look like this. So now I just need to the right of 2. So let's look at 3. If you plug in 3, you're going to get positive 4/5. Okay, so which is about right there, not quite 1, just a little less than 1. If you plug in 4, you are going to get a positive 1/3, which is about right there. So again, you can kind of take the shape of your graph here. Now, I understand graphing, there's a lot to it. So I am only expecting you to do one homework problem if you're doing the Delta Math. If you're doing the paper version, there are a couple that you do have to sketch a graph of. Okay, again, let me know if you need help.